Hello everyone, welcome to the RFID Kit for Arduino tutorial series. We've watched lots of competitions in various aspects. Usually there's an exciting part, in which people need to strive to be the first to press down the button for question answering. Thus, organizers need to prepare an answer machine which determines the quickest competitor in an accurate and fair way, and at the same time, the audience can see the result. With the answer machine, the race can have more possibilities and get more entertaining. So in this experiment, we will use buttons, buzzers, and LEDs to simulate an answer machine. In the competition show, the organizer presses down the reset button, and then the competitors get ready for pressing their answer buttons. When a certain competitor succeeds, the buzzer beeps and the corresponding LED lights up. To start a new round, the organizer needs to press down the reset button again. Okay, now let's get started. First, let's look at the experimental phenomenon. Press down button 4 to reset. Then press button 1. The buzzer beeps and the corresponding LED lights up. Press down button 4 again to reset. Similarly, press button 2 and the buzzer beeps with the corresponding LED lighting up. Now let's take a look at the components. The SunFounder Uno board, a USB cable, some jumpy wires, 4 LEDs, 4 resistors of 220 ohms, 4 buttons, and an active buzzer. Now let's study the principle of the experiment. Button 1, 2, and 3 are answer buttons. When button 4 is a reset one. Press down button 1, then the buzzer beeps and the corresponding LED lights up when other LEDs go out. Before pressing other buttons, remember to press down button 4 to reset first. Okay, we've got the principle and let's build a circuit. Plug the 4 buttons and the buzzer into the breadboard in a row for the convenience of observation. Then connect button 1, 2, and 3 to pin 2, 3, and 4 of the SunFounder Uno board respectively. The buzzer to pin 5 and button 4 to pin 9. Next, plug 4 LEDs into the breadboard. Connect a resistor of 220 ohms to the anode of each LED. And then connect the resistors to pin 6, 7, 8, and 10 of the board respectively. At last, connect the cathode of the LEDs, the cathode of the buzzer, and the other terminal of each button together. And then connect them to GND of the SunFounder Uno board. Okay, the circuit is completed. Open the Integrated Development Environment, IDE for short. Since it may take a long time to type in all the code in this experiment, we should just look at the finished code in detail. Now I go to the path where the code locates. Open the file. Okay, let's go through the code. Here we use button 1, 2, and 3 to represent 3 competitors and the button 4, the organizer. Connect button 1 to pin 2. Connect button 2 to pin 3, button 3 to pin 4, button 4 to pin 9, and the buzzer to pin 5. Then connect LED 1 to pin 6, LED 2 to pin 7, LED 3 to pin 8, and LED 4 to pin 10. Here uint means unsigned integer. We just say uint. And 8 means 8 bits. Define uint8 as an unsigned char type. For example, the uint8 flag below means defining flag as an unsigned char type. You can take it this way, unsigned char flag. The type helps make the program more organized. The flag indicates the status of button 4. B1 state, B2 state, B3 state, and B4 state are the status of button 1, 2, 3, and 4. Initialize them as 0, which is low. The function pin mode is to define the output or input direction of a pin, so you can set it by the arguments output and input. Type in pin mode and then buzzer pin and output as the arguments. It is the set buzzer pin as output. Similarly, set LED 1, 2, 3, and LED 4 as output. Next, we set the 4 buttons as input with the pull-up resistor inside. What can the resistor do is, when the button is not pressed down, the corresponding pin will be pulled up to high level. When it is pressed down, the pin will be low. That means, with the resistor, even when the button is not pressed, the corresponding pin can keep a certain voltage. Then set all the LEDs as low, thus turning them off. The function digital write is to set the pin at low or high level. Here we set all the 4 LEDs as low, then turning them off. Then we add a loop function, which as the name suggests, loops consecutively, allowing your program to change and respond. The function reads data from button 4 to B4 state. Since the button is connected to ground, if it is pressed down, the corresponding pin will be low. So this if function is to check the status of the button, whether the button is pressed down. Add a second if function to reconfirm, just in case a single press may appear like multiple presses. If the button is pressed down, the flag is 1. Then turn on LED 4. Delay 200 milliseconds. When button 4 is pressed down, the LED connected lights up. After a while, all LEDs go out. Here, if 1 equals to flag, which indicates button 4 is pressed down indeed. If yes, read data from button 1 to B1 state, button 2 to B2 state, and button 3 to B3 state. If B1 state equals to 0, it indicates button 1 is pressed down. Set the flag of button 4 as 0. Call the function alarm. It causes the buzzer to beep for a while till it stops. Now let's take a look at the function first. Set the total time for the buzzer as 100 milliseconds. We set the values so the buzzer beeps 2 milliseconds and stops for 2 milliseconds in 100 milliseconds, and then the loop ends. Set the buzzer as high for beeping, delay of 2 milliseconds. Set the buzzer as low to stop it from beeping. Another delay of 2 milliseconds. This part is to set the buzzer to beep, and after a certain period, stops. If you change the delay, the frequency of the buzzer changes, which means you will hear different hums of the buzzer. Then let's back to the loop function. Turn only LED 1 on, set LED 1 as high. Set LED 4, LED 2, and LED 3 as low to turn them off. Add a while function. Read the value of button 4. If the value is low, it indicates the button is pressed down. Thus, the while loop exists. So, only when button 4 is pressed, a new round of answering can begin. Now let me wrap up this part. When button 1 is pressed down, the buzzer beeps. Set the corresponding LED as high, thus turning it on. Similarly, use an if function. If button 2 is pressed, if yes, the flag equals to 0. The buzzer beeps. LED 2 is high, thus turning LED 2 on. In this part, when button 2 is pressed down, the buzzer beeps, and corresponding LED LED 2 lights up. See if button 4 is pressed. If yes, exit the loop. In the same way, if button 3 is pressed, if yes, the flag is 0. The buzzer beeps. Set LED 3 as high to turn it on. In this part, when button 3 is pressed down, the buzzer beeps and corresponding LED 3 lights up. See if button 4 is pressed. If yes, exit the loop. Compile the code and check whether there's any error. Not connect the SunFunder Uno board with your computer to download the program. Then let's see our fruits. Suppose the organizer presses down button 4 to reset. The corresponding LED lights up. Then competitor 1 quickly presses down button 1 during the race. Then the buzzer beeps and the LED connected lights up. After the current round is done, the organizer presses down button 4 again to reset and start another round. Similar to the previous situation, competitor 2 defeats the other racers and presses his or her button, which is button 2. Then the buzzer beeps with the corresponding LED lighting up. So this is our experiment. Interesting, right? You may not get the fun until you do it yourself, so give it a try. And here's exciting news. In the next lesson, we're going to meet another new device which transforms light to electrical signals. Really looking forward to that. So don't forget to follow our next episode. If you have any questions or suggestions, visit our website www.sunfunder.com to leave a message. Thanks for watching. See you guys.